Hello children. In this video, I'm going to explain few questions from the exercise 1.4. Um, in this exercise, you are going to learn and prove few irrational numbers. Okay. What are irrational numbers? So take your pencil and be ready with your textbooks. This definition is important. Even though you need to learn the proper definition, right? A real number is called irrational if it cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. A real number a real number, see, rational and irrational. Combination of rational and irrational is a real number. So, a real number is called irrational. When it is called irrational, if it cannot be written in the form of p by q, if you cannot put it into the form of p by q, rational form, then it is called as a irrational. Some examples: root 2, root 3. For example, if I say only 2 by 1 you can write, right? Yes. So if I say just 3 by 1 you can write simply, right? So root 2, root 3, root 15, you cannot define these values. Okay. Pi value. Pi value, you say that 22 by 7, it is a p by q form only. Now, why it is a irrational number? It's not, you should not consider pi value here as a 22 by 7. You have a decimal value 3.1478 something so on, which is non-terminated, non-recurring decimal. No numbers are repeating in this, and it is non-terminating. It is not at all terminating somewhere. So this is called irrational number, non-terminating, non-terminating, and non-recurring, non-recurring, recurring. Decimals are called irrational. Decimals are called, this is another definition. This is one definition, this is another definition. These are called real numbers. Okay, sorry, irrational numbers. This point is important. Next, one more point you have to know. Let P be a prime number. If P divides a square, then where a is a positive integer, if P divides a square, then P divides a also. P divides a square, then P divides a also. Suppose 27 is there. Okay, I'll take C, control N. Okay. For example, P divides a square. P is a prime number. What is a prime number? Take some P value as a here 3. Okay. P divides a square. Okay. P divides a square. A value. A is any positive integer. That square you have to take. So you can take 20. Sorry, not 25. Suppose 9 only you take 9. Okay, if P divides a square, then it will become, okay, 81. Suppose 81 you take. A is 81. 9 square, na? It is 9 square, 81. Okay. If P is a prime number, I took any prime number. If P divides a square value is here. A value is 9 I have taken. So a square value is 81. Then P divides A also. P divides A also. What is A value here? A is 9, right? So it divides, this P divides A also completely. Got it? So this statement is important. Proof is not much important. Statement is very important. Okay. Next one. Yeah. One more thing. See these example questions you will understand when I explain the exercise questions. You need to refer these examples also, which are important. Next, yeah, these things. Remember these things. First one, sum of two irrational numbers need not be irrational. Two irrational numbers. See, root 2 and opposite of root 2, negative root 2, they have a taken. If they sum means added, root 2 minus root 2 is 0. So which is a rational? Okay. It need not to be irrational, means it may be a rational or it may be a irrational. Okay. For example, if I add root 2, sum of two irrational numbers, another irrational number root 3. So the result is the same. You can't do anything here. Okay, root 2 plus root 3. This is one irrational number. The result is irrational only. Sometimes you may get a rational, sometimes you may get a irrational. So the sum of two irrational numbers need not to be irrational always. Sometimes rational also. This means next. The product of two irrational numbers need not be irrational. Product of two irrational numbers always need not to be irrational. Sometimes it is rational also. How? See, they have given one example, root 2a and 3 root 2b. They have taken a into b. Product means into only, na? A into b. So root 2 into 3 root 2. What it gives? 3 root 2 whole square. Square and root get cancelled, or 2 2s are 4, 3 root 4 you can take. Root 4 value is 2, again 3 2s are 6. So a by value is a 6. 6 is nothing but a rational. Okay. Suppose if you take root 2 into root 3 simply, two irrational numbers if you product, you can multiply 2 into 3, root 6. Okay, this is irrational. Okay, sometimes you will get the result rational, sometimes you will get the result irrational. So product of two irrational numbers need not to be a irrational always. Let's go to exercise 1.4. The first question, prove that the following are irrational numbers. 1 by root 2 they have a given. Actually, irrational numbers are like this. Root 2, 1 by root 2, 2 plus root 2. Okay. 2 plus 3 root 2. Okay. And root 3 plus root 5. Like this, they are the forms. This is mixed. Here also mixed. This is also mixed. Okay. This is sum of two irrational numbers is a irrational. So you need to prove this kind of sums in this exercise. First one we will see, 1 by root 2 proof. Okay. The question, first question, number 1, 1 by root 2. What we have to prove? We need to prove that 1 by root 2 is a irrational number. First, we will take 1 by root 2 is a rational number. We will take and check. Okay. Let 1 by root 2 is a rational number. So 1 by root 2 is equal to, rational number means it is a p by q form only, na? Here we need to very much clarify that the p by q, here p and q are belongs to integers. Okay, z belongs to symbol. This is p and q are integers, and where q should not be equal to 0, denominator should not be equal to 0. Okay, and p, q are co-primes. Co-primes means these two are having a HCF 1. They should not have a common factor other than 1. Okay. So we need to be very much clarify that what is a rational number definition. So we need to prove that 1 by root 2 is an irrational number. For that I have taken a contradiction. I took that 1 by root 2 is a rational number. First, I suppose 1 by root 2 is a rational number. So each and every rational number is in the form of p by q. So I equalized to the p by q. And I defined here what is p by q. P, q are belongs to integers. Q is not equal to 0. And p, q are co-primes. That means p and q are having a HCF 1. Okay. So whenever we see an irrational number or a surd in the denominator, for removing this root, we will do the rationalization. In the 9th grade, you have learned about the surds, right? So here root 2 is surd. So for this, for removing this root symbol, we will rationalize. What is the rationalizing factor of root 2 here? Root 2 only, right? So rationalizing factor, rationalizing the denominator. Rationalizing the denominator. So 1 by root 2. So for rationalizing, we will take the same and multiply and divide, so that our question will not change. Okay. Rationalizing the denominator. Rationalizing denominator. Now what happens? 1 into root 2 gives root 2. By root 2 whole square. Root 2 whole square value is how much? Root 2 whole square is, square and root get cancelled. Simply it is 2. Okay. So 2 is equal to p by q. Now just leave this root 2 here and transpose this to other side. Here it is in the denominator. It comes to the numerator. 2p by q. What I told before? P is a integer. Q is also integer. When you divide both integers, then it is a rational number. Okay. 2p by q is a rational number here. But root 2 is a irrational number. Are they both same? Are they both equal? No. So we will put the same thing. Here 2p by q is a rational number. Is a rational number by the definition. And root 2 is irrational number. Irrational number. This is contradiction to our assumption. This is contradiction. Contradiction to our assumption. To our assumption. What is our assumption? 1 by root 2 is an irrational. 1 by root 2 is unrational. 1 by root 2 is a rational number is our assumption. But here this rational number, again it became equal to the irrational number. They can't be equal, right? They're not same. So this is contradiction to our assumption. We conclude that therefore 1 by root 2 is an irrational number. An irrational number. Okay. Next question. Root 3 plus root 5. See, these two are, when we add two irrational numbers, we will get the result also irrational number only. So let's do second bit. Root 3 plus root 5. Same. While proving it is an irrational number, first we will take the contradiction method. Let us assume the given number is a rational number. Okay. Let us assume root 3 plus root 5 is a rational number. When it is rational number, This will be obviously equal to the P by Q. Here we need to define P and Q are belongs to integer. Even you can mention I also. And denominator should not be equal to 0. And also the P and Q are co-primes where HCF is equal to 1. So we defined here. Isolate this any one of the irrational number, root 3 I isolated. Transposing this root 5 other side. Here plus root 5 will become minus root 5. Now let's do the squaring on both sides. Squaring on both sides. What do we get? Root 3 whole square is equal to P by Q minus root 5 whole square. Square and root get cancelled. 3 is equal to A minus B whole square formula. A square plus B square minus 2AB. So P square by Q square plus root 5 whole square minus 2AB. 2 into P by Q into root 5. So 3 is equal to P square by Q square plus square and root get cancelled. 5 minus 2 root 5 P by Q. Here what is an irrational number? Root 5. Transpose to the other side, bring this 3 this side. So minus 2 root 5 P by Q will become plus 2 root 5 P by Q. As it is, this one we will write P square by Q square plus 5 plus 3 if comes this side minus 3 it becomes. These two I interchanged. So 2 root 5 P by Q is equal to P square by Q square plus 5 minus 3 gives plus 2. Okay, we will isolate only an irrational number root 5. Rest other things we will bring this side. P square by Q square plus 2. This here, what happens? Here with root 5, the 2 and P by Q is multiplication. So when we bring this side, it becomes a division, right? So 2P by Q will become what? 2P by Q will become here Q by 2P. Reciprocal. It becomes a reciprocal. Q by 2P. Okay. So let's take LCM for this. So what is LCM? Q square, P square as it is, 2Q square into Q by 2P. 1Q get cancelled. So root 5 is equal to P square by 2Q square by 2PQ. P is integer, Q is integer, addition of two integers is an integer, multiplication of two integers is an integer. So integer divided by integer is a rational number. So right hand side we got a rational number and left hand side we have a irrational number as a root 5 and both can't be equal. So our assumption is wrong. Okay. This is contradiction to our assumption. So let's write, finalize. Here, root 5 is an irrational and P square plus 2Q square by 2PQ is rational number. Isn't it? LHS can't be equal to RHS, right? This is contradiction to our assumption. To our assumption. So, therefore, root 3 plus root 5 is an irrational number. This is how we can prove the irrational numbers. Next questions, remaining questions we can see in the next video. Keep watching my channel. Thank you.